Hello friends, IoT and embedded enthusiasts like us, we always find a difficulty. The main problem is initially we have to purchase a microcontroller and a series of microcontroller and then we have to do test on that. And that is really difficult. Every time purchasing the microcontroller and then programming it and then testing it is quite costly as well. So, what is the solution of this one? We are always looking for a simulation where we can upload our programs and see the output. If it works perfectly, then we can go for the actual microcontroller to purchase. So, our solution is Wokwi. Wokwi is the simulation tool that even doesn't need to be installed in your laptops. That is one AI based online tool where you can do a lot of simulations and a series of microcontrollers are present. So in those microcontrollers, you can actually go for different type of experiments and you can get the outputs. So you can see that as Arduino, ESP32, STM32, PiPico, all are supported there. So you can see that, like for example here, that Arduino, ESP32, STM32, PiPico, and their different variants with different programming languages are actually available. For example, Rust you can see, and MicroPython is there. So if you are very comfortable with MicroPython or Rust or C++, whatever you want, you can use. So these are the basic circuits, that is the featured simulation projects, which is already designed for your reference. If you want to know that how they are working and how different sensors and different output and input devices are connected there, so you can go through this one. This is just for your reference. So with this reference, it will be very easy for you to connect different type of sensors and different peripheral devices with this one. So, as this is our IoT series, we are going to use ESP32 because ESP32 is having capability of Wi-Fi and IoT is actually very easy here to be embedded. So let us go for the ESP32 based simulation. Once you click this one, you'll be able to see lot of different type of programs, and you can see the different variants of ESP32 is there. ESP32, ESP-S2, ESP-S3, ESP-C3, and friends, Wi-Fi is also there. So you can use whatever microcontroller you want. Plethora of microcontrollers are actually present here. So let us go for ESP32. We have to first select the ESP32 microcontroller. So once you select this one, you will see that right side the microcontroller is appearing and in the left side the program is available. So ESP32, let me enlarge a little bit. So you can see that here we just want to see that what all the possibilities are there in the simulation. So left side you have to write the program and accordingly the same thing will be happening in the right side. So let us paste the basic blink program. So there we'll just blink the microcontroller's LED inbuilt pins. So those will be easy. In most of the microcontroller, there is LED pin is embedded. Like you know that in Arduino, pin number 13 is that one, and here this is pin number 2. So that pin number 2, I want to just tweak and see what output comes. So pin number 2 is the embedded LED. So this left colored LED is for power supply, and the right colored LED is for your connected with pin number 2. And it means digital pin number 2. So left side, whenever the power comes, it gets on. Right side, whenever digital pin 2 is getting high, that time it will get on. So that is the basic idea. So now what we'll do is we'll just just run the simulation and see that what output is going to come with this. So yeah. So now just we have to know a little bit of program also. So left part of the code is actually, you can see that void setup part of the code is for your one-time running of the code. The complete code will run one time. That is for initialization purpose. Which pin is output pin, which pin is input pin, that you have to declare there. For that part, void setup part of the code is there. Void loop part of the code is for that part of the code only will be continuously running. So you have to write, if the code you want to run continuously, that part of the code should be written inside the void loop part of the complete program. So digital pin 2 is getting high means what will happen in this case? LED is actually inbuilt there. So that will get on for 1 second. 1000 millisecond is 1 second. And that will get high. Digital right means it will get on and off. So because digital means 5 volt or 0 volt or maximum volt and minimum volt. Like that. So it will become low for 1 second and high for 1 second. So that one is there. Just run the simulation and see. You can see that right colored, blue colored LED that is connected with pin number 2 is blinking right now. So why it is blinking? Because we have given pin number 2 digital pin high and low for 1 second. Now what we have to do, we have to just increase the simulation speed to see that what effects are happening. So instead of 1 second on and 1 second off, we'll give half second on and half second off. So if 500 millisecond on, 500 milliseconds off. Now run the simulation and see what output is we are going to get. So it will take some time based on your internal connection. And you can see that now the blue color light LED is blinking a little faster because it's blinking in 1 second 2 times. Now, next what we are going to do, we are going to add the practical LED in that, like one external LED that we have to connect. You know that every LED will be having one anode and one cathode. Anode means negative and cathode means, cathode means negative and anode means positive. So cathode part we have to connect in ground, and anode part of the code, anode part of that LED we have to connect in this positive. Now that output of every microcontroller is 3.5 to 5 volts mostly. So that will, and for the LED that is 1.5 to 3 volts. So we have to reduce the current. To reduce the current, we have to add one resistor. So the resistor I'm going to connect here should be having the rating of 220 ohm, because that is sufficient for 3.5 to 5 volt of input. So that I have changed. You can change like this only. And you know that we have to connect accordingly, and it should be connected in ground because it is C. C means cathode. Whenever I click on the leg, you will be finding that C
Subscribe for more upcoming content.
C represents cathode and A represents anode. Now we have to connect this one with the ground, and the same way we have to connect. We have to make it black because black represents negative, and that another one anode pin we have to connect in pin number 2, digital pin 2. So that we have to make it again. Overlapping doesn't matter here because overlapping will not be considered as short circuit here. So we'll change this to red color. So it will be easy for you to understand that what is what. Now, once we are on the simulation, you can see that what the blue colored LED was blinking the same way. This our new LED is also blinking. So like that, we can just off the simulation, and you can see that here a lot of other devices are also there. Lot of LCDs, different type of sensors, different type of buttons, and multiple sensors. Additional sensors are also there. Then input output devices, then breadboard, then different gate sensors, gate devices. Everything is actually present here. So that is very easy to simulate in Wokwi. So our series actually concentrates on this one. And with this, we end this introduction session.
Don't forget to like this video and also subscribe to my channel.